There we go. All right, let's start. So, what I want to do for today's lesson is show you guys how to do the Part B calculations. The good news is that it's kind of a bit of a double dip because these calculations you'll be doing in Part C as well, just in a different direction. So one's going to go basically forward, one's going to go backwards kind of thing. If you guys remember, I am I'm trying to use as many assessment style questions as possible just so you guys can get familiar with it. So if you guys remember, if I printed on blue paper, this is the teaching example, is everything that's on blue paper, so that way you can follow the thread. Remember that this is a 4-part assessment, so now we're moving on to the second part. So if you want to be able to refer to what you did in the first part, look for the blue paper. Does that make sense? The practice ones that you guys are doing and I'm giving you feedback on is going to be yellow paper if you guys haven't realized, and then stuff that is just like a packet of questions are on white paper, and then your assessment is going to be on white paper as well. Does that make sense? We're looking at colors. No. All right. Blue paper equals the examples that I used as teaching. Yellow paper is the stuff that you guys have done as a practice, like a practice exam. And then white is everything else. Cool? What else did I want to say? So this is following up from the Part A. Now we're on to Part B. All the calculations that I have been talking about previously, the mass to mole conversion, the concentration equation, you're going to be using in this example. And so I want to show you guys how we're using what we've talked about theory-wise in the assessment section. So one of the things you have to remember when we are doing titration is, you know how you have your unknown solution, which is, say, for example, diluted buttermilk, and you're trying to figure out the ethanoic acid in there, and then you titrate it against the sodium hydroxide, correct? And I tell you what the concentration of sodium hydroxide is. Now, before you guys do that titration, I need to verify that that sodium hydroxide is the right concentration. So I'm going to do a pre-titration step before you guys do your titration. So this Part B is the pre-titration step. So this one is being used to verify that my sodium hydroxide is at the concentration that I've been saying it is at. So what I want to show you guys is how we go through it step by step to do these calculations, and then basically at the end figure out the concentration of my sodium hydroxide. Are we good so far? All right, cool. So what I'm going to do is I'm going to answer this completely first, and then I'll break it down for the achieve, merit, and excellence components. So in this first example, and you guys have the same copy, I'm just going to zoom up so you guys can hopefully read it a little bit better. You are standardizing your sodium hydroxide to make sure that it is an accurate concentration. And for us to do that, we are going to be titrating it against a known concentration of sulfuric acid. So I know the concentration of sulfuric acid. I'm going to try to match it against the sodium hydroxide to verify the sodium hydroxide's concentration. What you will always be given is an equation, and that's going to be important later in our steps, and that equation will be balanced for you. So we have the sodium hydroxide and we have the sulfuric acid. We have a neutralization step occurring, and we're using the exact same kind of methods that we would use when you guys are titrating. So first thing I'm doing is I'm going to verify what my sulfuric acid is and do those calculations there. So what they want us to do, and all of these steps are broken down for you, so you don't have to memorize the steps of how you do these calculations. It's scaffolded for you. So step number 1 is that conversion from mass to moles, as we're used to seeing. So they tell me that I have 1.79 grams, so that's my M, my mass, weighed in a laboratory, and I've added it to a 250 milliliter volumetric flask. That flask was then made up to the volume of that flask with distilled water and made sure that I was shaken until fully dissolved. So that here is my volume. It's really useful when you guys are reading these questions to go through and annotate the different bits of information they're given to you, so that way you can find it later when you're doing your equations. Cool. So in step number 1, I need to convert my mass to moles, which you guys have seen previously, and they have given me the molecular mass of my sulfuric acid. So that is my big M. So you see how all this information is given to you so far. All right. So they want us to calculate the moles of sulfuric acid that I'm dissolving. So, and again, they've given us the equation here. So I'm going to give you all the equations. You don't need to worry about memorizing them. So I'm just going to circle it so I know that's my equation I'm going to use. Now my equation is set up currently to solve for moles, which is good because that's what I'm trying to solve for. So let's start plugging in information. So my little m is 1.79 grams. My big M is 170.08 grams per mole. I personally like to write down the units so that way I can check that I've set up my equation correctly. So grams and grams will cancel. And if I get my calculator out, don't know if you guys can see that. There we go. Now you can see the calculator. 1.79 divided by 170.00. And I get this long number. I want you guys to leave that long number out because we only round at the very end of our calculations. It's useful if you have one of the nicer calculators because you can actually store the answers, or you can just make sure that you don't clear your calculator so you can use it in the next equation. So I'm going to write 0.01052445991 because I'm not going to round it, remember. We save it till the very end, and my units is moles. I've done things correctly. Are you okay with that so far? All right, keep going. Okay, so that there was my N value. And now that I know my N value, I'm going to calculate the concentration. And again, they've given me the equation. So the concentration for sulfuric acid. What's up? Oh, do you want pen or pencils? I'm gonna lay those out. Here you go. Pen, pencils. Calculators, if you guys want calculators to follow along. All right, so you guys can hopefully see where this is going. Once again, I have my concentration is equal to the amount divided by the volume. So this here is my amount. So I'm just going to copy that long number down. And I'm dividing it by volume. Now, something you need to keep in mind is that you need to make sure your volume is in liters. So if I have 250 milliliters, how many liters is that? Divide it by 1,000, so 0.25 liters. So that's what I put down here. And like I said, it's useful to keep things in the calculator because now I don't have to retype out that answer. I can just go divide and it's going to take that answer, 0.25, and then that's my concentration. Again, leave the number nice and long. We will round at the very end. So 0.04209 78363, and that's moles per liter. We good so far? All right, I'll leave that up for a second for you guys to make sure you got that down. All right. Moving on. Okay. So, are you okay? Move it? Okay. So now that I know that, I'm going to start using my sulfuric acid solution in my titration. So the first thing I need to do, if you guys remember, is you remember how we saw that equation here? And this equation here is comparing moles to moles. And right now I have a solution that's in concentration. So what I need to do is take that concentration, take a set volume of it, and figure out how many moles of sulfuric acid do I have in that solution that I'm using for my experiment. So now we're starting to use a new value for my volume, and that's the 25 milliliter sample. So I made my solution, and now I'm taking an aliquot of that solution out, and I'm asking myself how many moles are in that aliquot that I take out for the titration. Are you okay with that so far? All right. So once again, I have this equation here, but this equation is not set up in the orientation to allow me to solve for amount now. So I need to rearrange this equation to solve for n, and when I rearrange that equation, n is going to equal C times V. And you guys were doing this the other day. We good? Start plugging in some numbers. All right, so n equals, and once again, everything follows the sequence. So most commonly, the number that you just figured out in the last step, you're going to be using in this new step. So I want the concentration. I get that concentration from what I've just calculated before in number 2. If you want to kind of keep your work tidy, I'm happy if you don't write all the numbers down. You just do ... I'm happy for you to do that. Just make sure you use the unrounded number in your calculations. All right, so I have that for moles per liter. Oops. And I multiply it by the volume. Now in this case, I want the volume of the aliquot. You're not using the whole solution at once. So the new volume we were using is the 25. Again, we need to divide that by 1,000. So we're multiplying it by 0.025 because we want to convert it into liters. So this into liters is 0.025 liters divided by 1,000. Okay with that? All right, so just do that multiplication step. So we're timesing it by 0.025, and we get an answer of 0.001. And again, I leave it unrounded so that way everything can get rounded at the end. It's super accurate. I don't accidentally make a mistake. And again, look at the units. I see liters cancels with liters. I'm left over with moles, which is what I want, and that's the amount. So if I had a 25 ml aliquot of my sulfuric acid solution, I would have that many moles of sulfuric acid. Are we okay so far? Keep going. All right, now we talk about stoichiometry, which is using the ratios in the equation to state, okay, if I had this much of sulfuric acid, how much would I need of the sodium hydroxide? So I see here that there's no number in front, so that's just a 1. And I see how this is a 2. So I have a 1-to-2 ratio of the sodium hydroxide to the sulfuric acid. So if I was looking at that question then, what do I need to do to figure out how much sodium hydroxide I need? Times it by 2 because it's double the amount. So I'd take the answer that I found up here and I'd multiply it by 2, and that tells me how much sodium hydroxide I need. So that 0.001052, we can do ... to save us all the writing time, multiplied by 2, and that gives us the moles for the sodium hydroxide. If this was a 2 and that was a 1, what would I do instead? divide by 2. Don't worry, I'm going to give you guys plenty of practice problems. So for this guy over here, I am writing down, taking that number, timesing it by 2, and writing that new answer there. I don't know if you guys can see my calculator. Now you can see it. Again, like I said, it's good not to clear your calculator because then you can just put the long answer. So that is 0.0021048918, and then that's going to be in moles because I haven't done anything. All I've done is just multiplied. You okay? All right, keep going. All right, told you there's going to be some math and chemistry. All right, back page. So I want to figure out the concentration of my sodium hydroxide, but I can't do that unless I have a volume, correct? So then what I need to do is figure out the volume of sodium hydroxide. Now we're going to get the volume of sodium hydroxide by doing the titration and using the values from the titrate. So that's where this table comes into play. What we're going to need to do, if you guys were doing the titration, and you guys, like I said, the part C calculations are very, very similar. You're just working in reverse kind of thing. So we're going to figure out the titrate volume. We just need to do a simple subtraction. So that one's easy because that's 0. This one is going to be, and you see how those two numbers are the same? It's because they did the next titration from the same burette. They didn't refill it. So that saves them some time. So if I do 34.03 and I minus 16.83, I get 17.17. Cool? Next one there, I have 18 minus 1.3, so I get 16.70. Remember with the burette, you're reading it to 2 decimal places because you can assume halfway point. And then we have 34.9 minus 18, and that gets me 16.90. Are we good with that so far? All right. So you need to calculate the average volume to 3 significant figures, including units, and we want concordant data. So concordant data is data that is within a range, and I have to just double check the range. I think it's within let's see, a range of 0.3. So the minimum value and the maximum value should have a difference of 0.3. If it's any further than that, then I'm not going to be able to get merit. So we got to exclude some data. So if you guys think about it in biology, remember how you were removing outliers? It's the exact same thing that we're doing. We're removing outliers. So what I want to do is my first thing that I'm going to check is I'm going to check the lowest and the highest just to see if I can use all 4 data points. So this is my highest point, is that 17, and my lowest point is that 16.7. So I just want to do a quick subtraction step to see if that range is acceptable. And it's not. When I do this range, it is 0.47 milliliters. So that range is too large. So now I need to decide what number to eliminate. Are we okay with that so far? All right, so let's say I eliminate the 17. Then my new highest value is going to be that 16.9. And the range there is 0.20 milliliters. So is that within the range?
Yes.
Of 0.3? Yes. So I can accept this one and exclude that one. The next thing I can check is the other one. Let's say I eliminate the 16.8 instead. My next lowest number is 16.83. So let's see the range here. It's just to help you decide which one you want to eliminate. So this range is just a little bit too high. This one's 0.34 milliliters. So I'm going to eliminate the 17.7. Does that make sense to why I did that? If you have them working at both ends, then it's your choice. It's your judgment call. But you should eliminate one of them, and I'm going to be eliminating the one that is that 17. So we're going to exclude that data from my average. So when I do my average, I'm going to use 16.83, 16.70, and 16.93, and I'm going to divide it by 3. Make sure you are careful when you enter it into the calculator, because you want to make sure all those things get added first and then divided by 3. So you can either use parentheses, or you can just do the addition first and then the division. Let me show you something that would be like why I would make a mistake. So if I just added all those numbers in and then I hit divide by 3 like that, you see how the average is coming up as 39? That's clearly wrong, all right? Average number should actually fit within what those numbers are. You shouldn't have any number that's really, really high. If you've done that, all you've done then is divided the last number by 3. You haven't divided the other numbers by 3. You'd be surprised how often that happens. So I'm going to add everybody together first. Then I'm going to divide by 3. And I get 16.81. Now, on this piece of paper, you notice how it says 3 significant figures? So 3 significant figures, that's your first one, that's your second one, that's your third one. So this is the one that you're going to end on, and you're going to round up or down depending on the final number. Do you guys know about rounding? So if it's 5 plus, you round up. If it's less than 5, then you round down. So in this case, it's a 1, so my final answer will be 16.8 milliliters was the average Thai tray. Okay with that so far? Ready for the final step? Brooklyn, you're shaking your head no. What's not making sense? It's good now? Any questions? What's the question? Huh? Oh, do the next one? Okay. All right, last thing then is we are now going to combine the information from question number 4 and question number 5 to figure out the concentration of the sodium hydroxide. And they tell you that use the average volume from the concordant sodium hydroxide titrates in question 5 and the calculated amount of sodium hydroxide in question 4 to determine concentration. So this here is your volume. On the previous page, you have your concentration. Sorry, your amount. So concentration is equal to the moles divided by the volume. So I have the concentration from that previous page was 0.002. Let me just write it on my calculator. Moles. Just gonna write it down here. All right, 0.002104898 moles, and that's from question number 4. And I'm dividing it by my volume. Again, we need to convert this volume into liters. So that 16.8, when you convert it into liters, is 0.0168 liters. So I have 0.0168. I'm going to use the actual leftover 1 because then I can have it more accurate with my calculation, and that's in liters. So I just do that division, and we see how we now have moles per liter in the right spots. So I take that number, I divide it by 0.01681, and that's my concentration So concentration equals 0.125 to 166,449 moles per liter. Once again, I want it to 3 significant figures. So that's my first one. We don't count the 0 in front. We only count once numbers start appearing. That's my second one. That's my third one. So this is where I'm gonna end and round. So I see over here, is that less than 5? Yep, so I round down. So 0.125 moles per liter. And then I'm done. That's part B. All right, I'm gonna pass out the marking schedule so you guys can see what the Achieve, Merit, and Excellence requirements are there. Again, I'm trying to put things on the same color so that way you know which one's fine and which one. So here's the marking schedule for B and for C. So B and C tie together because the calculations are very similar. All right, so let me go through and tell you guys some things. So, for the Achieve, there's multiple ways you can get it. The first part is that you correctly calculate the concentration of sulfuric acid. So this first step here, if you get this one correct, then that's achieved for this overall section. You don't need to do the rest of the calculations. Nice? Yeah, you're like, I can do that. All right, the other way, because you see how there's lots of or options, or makes a mistake in the first half of the calculations, somewhere in question 1 through 4, and that mistake carries through, and it then makes sense for the concentration. So your concentration calculation is incorrect, but I can catch where that error is, and I see that it's followed through. Don't make a mistake on purpose. Let's say you make a mistake on accident. All right? So just a mistake, and that mistake carries through, and the rest of the calculations are set up correctly. It's just a mistake has come through. The other thing, part D, there's a calculation there, and I can take that as evidence. I can also take your part A. So let's say that you are able to show me your dilution calculation. I can still mark you at the Achieve level. So that's the good news, is that if you make a mistake here, I can take the evidence from other places. Are we okay with that so far? All right, merit requirements, again, is very generous. So you see how there is an or option here. So basically, you need to do the calculation correctly once. So either you do the calculation correctly for part B, or you do it for part C. So even if you muck up this calculation here for part B, you do it again in part C. If you can show me that you know how to do it in part C, you can still get a merit. All right, so this one's correct calculation. The other thing you need to do for the merit is the range. So when you collect your data over here, you need to do that concordant. So if you average all these numbers together, you're going to limit yourself to an achieved. So you should be eliminating any non-concordant data. You might have all 4 of these, and all 4 of these might be within the 0.3 range, and you can use all 4 if you want. But if any of those values are outside of that 0.3 range, then you need to remove something. Okay? So that's what you need for the merit, is just getting this answer right. Here or in part C. That's how you get your merit. Okay? The other thing that I'm looking for merit is you have that concordant data. Okay? Keep going. Excellence. All right. So like I said, you get 2 chances with the merit, which is quite generous. The last thing you need to do for the excellence is obviously you need to meet the merit requirements. In this case, you need to get part B and part C calculated correctly. So there's an and here. That's the only difference between a merit and an excellence in the calculations. So you get the right answer here. For excellence, it's going to be an and. Cool? All right, second thing I'm looking for is that consistency across your answers. So making sure you have 3 significant figures whenever I ask, and making sure you have units. So specifically where I've asked for the 3 significant figures and the units for this question is in part 5 and in part 6. So part 5, I should see 3 sig figs, and I should see the units, and that's for E. And again, down here, I should see 3 significant figures and your units for the E. So not a huge jump up to get excellence. Huge jump between achieve and merit, which is quite typical. All right, what questions do you have following from that? Nothing? All right. Those are the calculations. Okay, so what I've created is I've given you another packet of practice questions once I find them. All right, I made another packet of practice questions. There's only 3 practice questions here. I'm happy to create more if you guys want, or I can recommend other things to work on. With these practice questions, what I designed it for is for you to be able to rip them off and hand in just the 1 question so you can keep working on the other 2 questions. Does that make sense? All right, so you guys have the rest of the period to get some work done. I'm happy if you want to work on bio, because I know you guys have those microscopes, internals. Huh? I'll chat with you later. Or let me pass this out and then I'll chat.